One more important point to note here is that we are not restricted to creating only one handler in a playbook. For instance, we can create a separate handler for starting or stopping the services respectively. And if we want to notify multiple handlers, then all we need to do is to convert the notify directive to a list. For instance, we can convert this notify construct to notify start Apache and notify team. And in this case, the notifications will be sent to both these handlers and they will execute in sequence. For now, we will just configure one handler and it will be start Apache. Here, let's make sure the state is started or restarted in the handler instead of stopped. In fact, we should specify restarted, which is a better option anyway. OK there, now looks like our playbook is ready to run. We will save our playbook and exit the editor. Let's explore another feature of playbooks here, that is dry run. Dry run will basically verify the playbook to check whether Ansible can run the playbook without making any actual changes to the remote hosts. It will run the tasks in a simulation mode, as if it was actually going to make the change. We can play the playbooks in dry run mode by specifying a -- check argument. When Ansible -playbook is executed with this option, it will not make any changes on remote systems. Instead, any module instrumented to support check mode will report what changes they would have made rather than making them. Most of the primary core modules support check mode, but it is not required that all modules must support this mode. Be careful about using this option. Please do refer to the detailed documentation of the Ansible module you intend to use with this check mode. The modules that do not support check mode will also take no action, but just will not report what changes they might have made. Although check mode just runs the Ansible playbook as a simulation, however, it is great for basic verification of the playbook. Now let's run our playbook in check mode. Execute. Ansible -playbook apache _install.yaml -b --check. So it ran and we can see it output an OK status for all the steps. Let's log into the node and verify whether it really changed anything or not. Connect to the node via SSH. SSH Ubuntu at node 01. And now list the content of HTML directory. Execute ls/var/www/html/. And we can see our current .html file is not present here. So it did not copy over the file, which proves that our play of the playbook was actually just a simulated play. Let's log out of node 01. Now let's execute the dry run once again and inspect the output closely. Type Ansible -playbook apache _install.yaml -b -check and press enter. So this output is telling us exactly what would have happened if we ran this playbook on the remote server. It shows that it ran setup, which is OK, meaning it did not cause any change to the system. Then apt-get update ran, and it did cause a change, which is always the case. Next, it came to Apache installation step, and it reports an OK status, which means nothing would have changed on the system. This is because Apache is already installed and configured, so this is expected. Similarly, copy data files is also OK because the file is already present on the target server. Stop the service is OK as well, since the service has already been stopped on the target server. Copy template file has a status of changed. This is because the new template file, which is not present on the target server. It would have been copied over and hence the state of the system would have changed. So that is one task that would have caused a system state change, followed by the handler. Here the handler would have also caused a change, because it is responsible for starting the Apache web server, which is currently stopped. Alright, everything looks good, and we are ready to play our playbook for real. So let's execute our command again, but this time without the check argument. Ansible-playbook apache_install.yaml-b. Let's allow it a moment to finish. Okay, now the playbook is done. Let's log into the node and verify the current state of the machine. Log into the remote machine via SSH. And now list the contents of the HTML directory. Execute. ls/var/www/html. Okay, we can see a new file called current.html is present here. Excellent. Let's review the contents of this file. Execute. cat/var/www/html/current.html. It shows the contents of our current.html file, which matches the content of our original Ginger file, except the variable has been replaced with the real value of node01. So you can see templating can be very useful when we want to install particular software on the target machines, and we have to supply some specific variables in the configuration files for host-specific configuration. Let's log out of node01, and from our main Ansible machine, let's execute curl node01/current.html. So now this curl request gets a valid response with the content of current.html file from node01. Let's also quickly review the content of our original Ginger file. We will execute cat current.html.j2. We can see the contents of this file and where our Ansible hostname variable from the original file was replaced with the actual node name by the template module. Okay, great. So now you are familiar with some new Ansible concepts like templates, handlers, and notifiers. So basically, if you want to perform a single task in response to multiple events which may occur in a playbook, it is better to configure it as a handler rather than repeating it all over in the playbook numerous times. Our tasks in the playbook can just raise these events at the appropriate time and notify our handlers, and the handlers can take necessary actions in response.